Welcome back to the podcast, where we delve into the intriguing world of data processing and the technologies that drive it. Today, we're exploring the Unix philosophy and its impact on modern data processing frameworks like Mapreduce. If you've ever been curious about how data flows through systems and the design principles that simplify management, you're in for a treat. We'll break down some essential concepts, discuss the advantages of immutability in data, and see how these ideas manifest in practical applications. So settle in and let's jump right in. At the core of the Unix philosophy is a simple yet powerful idea. A program reads input, processes it, and produces output. This clear and predictable process allows you to rerun commands without worrying about unintended side effects. It's a crucial aspect of programming and data processing because it fosters experimentation. If you encounter a bug, you can easily revert to a previous version of your code and rerun the job. This ability to roll back is revolutionary, especially compared to traditional databases where a faulty write could lead to data corruption. This notion of human fault tolerance is essential in environments where mistakes can happen. It empowers developers to innovate and iterate quickly without the fear of irreversible damage. In agile software development, minimizing irreversibility is a fundamental principle, enabling teams to adapt and evolve their projects more efficiently. Now let's talk about Mapreduce, which, much like Unix, adopts the idea of treating inputs as immutable. Once data is read, it remains unchanged. Any output generated completely replaces the previous one. This immutability comes with several advantages. For instance, if a task fails during processing, Mapreduce automatically reschedules it. If the failure is temporary, the system can handle it. If it's a bug, the job will eventually fail after a few attempts, allowing developers to identify and fix the issue without losing any data. Another benefit is the reusability of data. The same set of files can be utilized across different jobs, offering flexibility to run various analyses or monitoring tasks on the same data. This makes it easier to evaluate outputs and track discrepancies over time. Additionally, just like Unix tools, Mapreduce jobs separate the logic of processing from the configuration of inputs and outputs. This separation allows teams to focus on creating efficient processing jobs, while others determine how and when to execute those jobs. Interestingly, the principles behind Mapreduce aren't entirely new. They resonate with concepts found in massively parallel processing, or MPP, databases that have been around for quite some time. Early systems like Teradata and Tandem Nonstop SQL laid the groundwork for parallel processing, but they required careful upfront modeling of data. In contrast, Hadoop takes a more flexible approach, allowing data to be dumped into a distributed file system in its raw form. This enables quicker data collection and processing, emphasizing the importance of making data available rapidly, even if it's not perfectly structured. By adopting a schema-on-read approach, Hadoop shifts the responsibility of data interpretation to the consumer. This flexibility proves particularly advantageous when different teams have varying priorities and needs. One captivating concept in the Hadoop ecosystem is the sushi principle, which suggests that raw data can often be more valuable than well-structured data. By allowing data to exist in its raw form, organizations can perform multiple transformations and analyses without being restricted by a rigid schema. This approach is especially helpful for implementing ETL, or extract, transform, load processes. Data from various sources can be collected in its raw state, cleaned, and transformed later. This decoupling facilitates more agile data handling, enabling teams to concentrate on data collection without getting bogged down in upfront modeling. Hadoop's architecture also supports multiple processing models, which allows for a diverse range of applications beyond traditional SQL queries. While SQL is excellent for structured data analysis, many modern applications, like machine learning, Image processing and recommendation systems require more flexible data processing capabilities. With Mapreduce, engineers have the freedom to write custom code for complex data processing tasks. This flexibility is a significant advantage over monolithic systems that may not accommodate various processing needs. Moreover, Hadoop allows different processing models to coexist on the same cluster, all accessing the same data files. This shared use environment simplifies data management and enables organizations to experiment with new processing models without needing to move data around. When it comes to handling faults, batch processing systems like Mapreduce exhibit resilience compared to online systems. If a batch job fails, it doesn't immediately impact users, as these jobs can be rerun. This resilience is crucial for long-running processes that handle large datasets. Mapreduce operates under the assumption that task failures are a normal part of the process. Instead of rerunning the entire job due to a single task failure, it allows for task-level recovery, which is more efficient. This design acknowledges that while machine failures do occur, they are infrequent enough that the overhead of task-level recovery is a reasonable trade-off. To wrap up, the Unix philosophy has profoundly influenced modern data processing frameworks like Mapreduce. By emphasizing immutability, clear data flow, and fault tolerance, these systems empower developers to innovate and iterate swiftly. The flexibility of Hadoop allows organizations to manage data in its raw form, paving the way for diverse processing models and efficient ETL processes. As we continue to explore the ever-evolving landscape of data processing technologies, it's evident that the principles of Unix remain relevant, guiding the development of robust and adaptable systems. Thanks for joining us today. We hope you found this discussion insightful and that it inspires you to think critically about the data processing frameworks you use. Until next time, keep experimenting and pushing the boundaries of what's possible with data.